Just so I get to know everyone here a little bit, who here works in QA, just to make sure? Okay, just me. Who here does manual testing as part of their job? Who here loves it? A couple of people put their hands up. That's exploratory testing. Okay. Who here actually writes code as part of their job for the testing stuff? Nice. Who would like to, but isn't doing it yet? Okay. I would say that's about 15%. So the reason I'm asking all these questions is because I started my professional life as a developer about 20 years ago. In fact, the first programming language I used was Visual Basic. Does anyone here remember Visual Basic? Don't hold it against me. I still remember it fondly. Okay? But I got to work in a lot of different programming languages in a bunch of different positions. And at some point, I really got into test-driven development, and from there, the spiral down into the whole world of testing, and the whole idea of the testing culture, and the testing pyramids, and all that good stuff came into play. I wrote a book called Art of Unit Testing about all the things that I learned the hard way. I'm currently rewriting it in JavaScript, because JavaScript, you know. And I wrote another book called Elastic Leadership, which is all about leading technical teams. And the reason I wrote that book is because there were many failures that I had as a tech lead trying to push the things that I believed are the right things. So it's not good enough that you know what is the right thing to do. It's not good enough that you know how to do it. The real problems begin when we jump into an organization. There's a bunch of other people around us, and we have to get them to do it too. So even if, as I was a team lead, it was still very difficult to get people to do the things that I thought were the right things to do. Can everyone in the back hear me? Raise your hand if you can hear me. Raise your hand if it's not good and you need better volume. Okay, that's good enough. I'm currently writing a third book called Pipeline Driven, which is basically what this talk is about. And it's probably going to be out in a year or so. I'm on chapter 3. And it combines the best of both of these worlds. Not only the idea of testing as a culture, but how do you actually push that into an organization that is driven by automation, driven by pipelines. And I'm going to explain what I believe that is. So there are three main things I'm going to talk about today. I'm going to explain, first of all, why should you even care about pipeline-driven organizations, right? How it affects everyone here, including myself, and how it affects the future. And I'm not just talking about AI, I'm talking about what happens today before AI exists in your organization, and how AI can actually contribute. I'm having some thoughts based on the previous talks. I'm going to introduce the idea of test architects and how that role might be useful in a pipeline-driven organization, because a lot of us are facing a lot of turmoil, a lot of transformation inside organizations. Whether we like it or not, organizations are going towards that area of continuous delivery, of automated pipelines, of automate everything, and then the question becomes, where do I fit in? So I'm going to suggest a place where we can fit in, but not just as a third wheel, but as a singular, a central part of that vision. And I'm going to introduce one specific practice called a test recipe, and how we can use it to combine QA and development working together. Because one of the things that I find is the most difficult in organizations is the people aspect. In fact, if we could get rid of people in the software lifecycle, everything would be much easier. If I could just work alone and not have to convince anyone, life would be much easier, because computers do exactly what we tell them to do. But we have to learn how to work with people, and a lot of the times people are missing not only technical skills, but also interpersonal skills, and I'm going to talk about one way that we can maybe try to mitigate it. So I already started saying that there's this whole this whole transformation happening to continuous delivery. And your organization is probably already part of that. I would say most organizations that I see, because I do a lot of consulting and training in different organizations, most organizations usually are just saying that they're doing continuous integration, continuous delivery. They use all the right words, but underneath, in the real world, everything stays exactly the same, just everybody has a different name, okay? So IT folks become the DevOps, and security become the DevSecOps, testers become the DevTestOps, AI become AIOps, whatever. It's just put the word ops in there. And I'm trying to think, what's the difference between all these organizations trying to do the right thing? I mean, there is a reason they're trying to do it. It's not just because of marketing, right? As an organization, I want to be better. I want to deliver faster. I want to do all that stuff that the Netflixes and the Googles and the Facebooks, I'm not talking about the spying, I'm talking about the delivery, that they do, all the good stuff. How do I actually get there? And if we look at what those organizations are doing versus what we're doing, a lot of times there is a huge difference. But that huge difference can be summed up in a few simple words. And I'll explain first by looking at the current state. So here's what I see in many organizations. They go towards automation and pipelines. And a pipeline, for those of you who are not sure when I say pipeline, I basically mean a bunch of automated actions that get triggered by some kind of either a button click or based on a commit or a check-in to source control. A pipeline is a set of actions that happen automatically. And they have an output, which is usually a fail or a pass result. So what happens in organizations is that they hear, okay, automated continuous integration. Well, dev have put in their own pipeline, and when dev run their pipeline, they run unit tests and maybe a few integration tests. And when the pipeline is running in the dev environment and it passes, a developer will usually, team lead maybe, will say, okay, I think we're good, and then they will hand off a version into the QA, and then QA will have their own pipeline with their own automated set of tools. And in their own automated set of tools, they will run their own stuff. Maybe it's automated, some of it's manual, but maybe they're going all the way in and they're saying, no, we have fully automated stuff. We're even using AI, just in case. And then if that passes, QA will notify the ops. It is time to deliver a new version into this environment, since we do not have permission to deliver to this environment. And ops have their own different pipelines. They might even deliver in a different way than dev and QA have been deploying the application. They might have their own set of documentation. They might do everything manually. They might do everything automatically. They might run tests, they might not. Nobody knows. It's a black box. And they're sitting there in a different office. And like, don't bother them because they're handling production. But just before production, maybe security is going to jump in and say, hold on, everybody. It was nice. You were all playing in your little sandboxes. But now it's my job to say whether this application is ready for real production. So the answer is no, which is usually what happens. And then this whole cycle comes back. Oh, there's this problem. Or it takes 2 weeks to verify that something has happened. So what is this based on? This is based on my experience in a lot of big companies that have a lot of different moving parts delivering a specific set of software. And what you'll notice is this is what I call a waterfall pipeline. There are a bunch of Jenkins jobs or TeamCD or TFS jobs running around in the organization, but we are nowhere close to continuous delivery or even continuous integration. The only thing we have is a waterfall based on humans. If we look at all these different categories and we try to compare that with these companies, what's the difference? Well, in the traditional waterfall pipeline organization, which I would say let's call it, if we had traditional waterfall before, and now we have just waterfall with automation, let's call it waterfall 2.0. It's very easy to say, hey, we're test-driven, we have automation, we have continuous integration. So why the hell does it take us 5 months to deliver a bug fix to production? And this is where the answer is, I think. So think about it like a huge waterfall. There's a bunch of people in the middle, and a software. This is basically part of our value stream. When people talk about value streams and value mapping, this would be a part of that. There's a whole section on the left that's missing, which is all about the requirements gathering and the design. So I'm not including that here because I'm only talking about the parts that currently have code in them. Now imagine you had Cucumber and automated features. You could add another stuff to there. But here's the thing. We can think of it as a pipeline of pipelines, okay? And the people in the middle are bottlenecks. Each person has to look at the results of the pipeline before them and say, yeah, I think it's okay. You can go ahead and run your own stuff. And then the person next to them will say, okay, I think that's okay, so you can go ahead and run your own stuff. And this is where I think most of the industry is today. A pipeline of pipelines with humans in the middle. What if we could get rid of the people in the middle? What sort of decisions do those people make? I would claim that those people are making tactical, day-to-day decisions. They're not making strategic decisions whether what is the right thing to build. They're not making strategic decisions whether a feature makes sense or what is the requirement, whether we should build the right product, right? They're making the day-to-day decisions about advancing a piece of code from one stage to another. So I call that tactical decision making. But what if we could get rid of those people and just say, if the pipeline is green, then just start the next pipeline. It sounds weird, I know. But if the pipeline is green, then just move on to the next pipeline. And if that pipeline is green, move on to the next pipeline. So if everything is green through all of these automated pipelines, then we should be able to achieve continuous delivery, right? And at this point, if there's no people, hey, let's parallelize it. There's no reason why we can parallelize a lot of these tests. We can still wait. Maybe we can even add compliance pipelines in the middle there and automate compliance checks. And there are many ways to automate compliance. Compliance is actually usually one of the easiest things to implement because it's all about checking documents, results of test reports, checking signatures. And since we already have all of the reports and all the answers from the pipelines, we should be good to go. So maybe that sounds already far-fetched. But if we consider what's the difference between a traditional Waterfall 2.0 company and the Netflixes and the Googles, I think this is the difference. The difference is that they have put trust in their pipelines to make the tactical day-to-day decisions for them. So what are the benefits? Well, if we, instead of making the decision as humans, code our decision-making as tests inside the pipeline, what do we gain? Well, instead of a person approving merging from one branch to another, or approving promoting a feature from one branch or one environment to another, the pipeline would make that decision. How? It would be green, and so the action would take place automatically instead of a person having to click it. Instead of approving or saying that a feature is ready or that a release is ready, if the pipeline is green, it's ready. Sounds weird, but I've been to those organizations where you would have the QA lead sign, sometimes with their blood, that the release is ready. Now, if that was me, right, and I was asked by higher management to say, do you agree, Roy, here and now, that this release, as promised, with all the bug fixing and the cherry picking between all the branches and the 55 people that have worked on it for the past month or so, do you agree that all of this is ready? No. I disagree. Because how would I know? I'm just one person. I have no idea what is the quality of those people. They're not me, I have no idea. So I would have to verify, right? So before I sign anything, before I give you my firstborn, I would verify the hell out of that. And of course I would still be wrong, but I would verify. And it would take me a long time because my job is on the line. And if I'm wrong, What happens? Maybe first time it's okay. Second time, what if I'm wrong the second time? I thought the release was going to be okay, and it's not. Third time. At what point do the leaders come in and say, there's a problem, and the problem is with Roy? Is the problem with Roy? No. Because we cannot actually know all of the intricacies that come in. The only thing that we are tasked with is to say, I think everything is okay, but what if we just say, no, the pipeline is either green or red. And if the pipeline is green, it's okay, and if it's red, it's not okay. That, again, brings maybe fear to some of your hearts. Can you actually trust the pipeline? We'll talk about that in a second. Security. Instead of security approving, security writes automated tests as decisions inside the pipelines. So instead of security approving, the pipeline approves. What about ops? Setting up an environment, killing an environment. Instead of doing that stuff manually, instead of asking permission, why doesn't the pipeline just create a new environment, deploy into that environment, run a set of tests, and kills that environment so that the next environment will be clean? We can make those decisions. The pipelines already know how to do that stuff. The advance of Kubernetes and Docker all over the place should make it very, very easy. But still, we have people in the middle of all of those decisions. Even in the age of dynamic environments, where it's so easy to just raise up a bunch of Docker images and load up an environment, still you have static environments and people that say, no, we have to build this up, and they build it manually, and they don't have, and it becomes this huge mess. So we've taken the old world and we've just put some lipstick on it. So the biggest thing to me about releasing the tactical decision-making from people and putting it in the hands of pipelines is stress, okay? Stress. Remember, the amount of stress that I have, someone that has to sign off on something, is much higher, especially when the amount of things that have to be verified is too big. So instead of this, instead of being stressed, if I trust the pipeline and I create a good enough pipeline, then if the pipeline has good decisions in it, then I should be able to just say, look, I didn't say the release is not okay, because maybe if I was a QA lead today and I would sign off on things, I might want to say the release is not okay, but just imagine the pressure on people to say the release is okay. We're in a time lock and we need to get this out, so just say the release is okay. So now I'm supposed to be the savior between humanity and the evil deeds of the bugs. I somehow have to be the person that says no while everyone is trying to get me to say yes. No. If the pipeline is red, what do you want me to do? The pipeline is red. A test has failed. So easy, so nice. I love it when tests fail. Okay, I love it. Because it means we're getting real feedback, and that feedback is not human. That feedback is cold, hard truth. Of course, if the tests suck, it's a different type. But that's a different skill. So how do we trust the pipeline enough to actually give it the decision-making ability? Because we want the pipeline to veto our releases. We want the pipeline to veto our deployments. Well, this is what I call SDLC 2.0. And in SDLC 2.0, the software development lifecycle, the next generation, is not just focusing about manual sign-offs, but they participate in a pipeline. I would say that 50% of the work, other than being creative, is about managing pipelines. So what is a pipeline really? In a pipeline, you have a bunch of delegates. It's like the UN. In the UN, you have a bunch of delegates, and they can vote on various resolutions. Do we agree that this bill is okay? And then, the representative from this country is saying, I disagree. And it only takes one representative, one delegate, to veto the entire decision-making process. So who do these people represent? They represent the different categories of knowledge in the organization, right? As a security person, I'm going to now teach the pipeline how to make a decision about security. I'm going to create a delegate in the pipeline that judges whether security is good enough in an automated fashion. As a developer, I'm going to write unit tests, which are basically delegates. And if a unit test fails, it becomes red, the build becomes red, and the entire build stops. So it only takes one test to fail a build. So if we wanted to veto, how do we veto a build? How do we veto a pipeline? Can anyone tell me? How do you veto a pipeline? Not people who were in my talk yesterday. Does anybody know? Who has worked with pipelines before? Edited Jenkins files, Circle CI, stuff like that. Has anyone? Okay. Those people, how do you make a pipeline fail? Can you tell me? No coffee. Roy, we need coffee. Well, I'll tell you. Just so happens I have a slide for it, of course. All you have to do is exit with a non-zero value from the process. If you wanted to break any pipeline in the world whatsoever, all you have to do is to create a script, create a piece of code, or anything that exits the process with a special exit code, which is non-zero. Zero represents success, and non-zero represents failure. In fact, if you look at almost any test framework out there, how does a test framework represent that a test has failed, that the pipeline should fail? The test framework process, the test runner, exits with a non-zero. So that's how you veto a pipeline. We need to learn how to veto pipelines, because we're going to have to learn how to create scripts that exit with non-zero. Exiting non-zero is a single line of code that we need to learn in a specific language. And here's the nice thing. Once you know this one simple trick, how to break pipelines and how to veto things, you'll realize that the entire software ecosystem around automation and builds agrees on this one simple thing, right? CI servers agree, all scripts and processes agree. If you want to represent failure, exit non-zero. That's it. That's the simple magic. So with this kind of knowledge in hand, we have to think, okay, if I can veto pipelines, and you want me to start adding all those automated tests, and they have to be good enough so that I can trust the pipeline, it means that maybe half of my job now becomes adding tests to pipelines. And I think that's true. I think security people were going to start adding tests to pipelines. That's going to be a big part of their jobs. And I think compliance, and I think ops, I think everyone is going to have a very interesting road ahead of them. So in many organizations, maybe you'd be surprised, but in many organizations, not just QA are feeling kind of threatened by this whole move towards automation. When I show these ideas to developers, developers are also feeling some pains. Developers have to learn a bunch of new skills. They have to learn how to not just work in a specific environment, they have to learn how to work in a full stack environment because they are working in feature teams in an agile fashion. They have to learn how to work with pipelines too, because it's the team's responsibility to work with pipelines, not the ops responsibility to work with pipelines. They have to learn how to write automated tests. A lot of developers maybe know how to write unit tests, but even that is still a practice that is missing in many organizations. And when there are tests, a lot of times, they're really bad. They don't know about security. They don't know how to work with pipelines. They don't know how to manage and understand environments. They just care about very simple, small stuff. You will find unicorns that care about all these things, but most developers have a lot of pain in this transformation. Ops people, IT folks, notice I'm not saying DevOps people, no such thing. Just call it pipeline-driven organizations instead of DevOps. Ops people, previously called IT folks, have a lot of pain in this new organization too. They have to learn about infrastructure as code and automating all these things. It's not just about learning Kubernetes and Docker. It's learning how to actually code. Because the next step after just having automated infrastructure is testing automated infrastructure. So not only do they have to learn how to code, they have to learn how to automate and write automated tests for that infrastructure so that they know that the environment is actually running. It's a long process. They would have to also learn a skill that's really missing for a lot of ops folks: coaching other people, sharing knowledge, sharing information. How many times do I see grumpy faces walking around the office. No, 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 I'm busy loading up the environment. No, don't, I'm done with the blah, blah, blah. No, no, that's not the world we have to live in today. In this world, everyone has to teach everyone because everyone has some skill that everyone else needs. If everyone needs ops abilities because they have to work with pipelines, and everyone needs coding abilities because they have to write tests, and everyone needs testing abilities because they have to write tests, right? So that means we have some skills. Security have to learn a lot of stuff. Security, I think, are way behind the curve. Developers have already started doing this transformation. Ops have already started doing this transformation. Testers and QA are starting this transformation, which is, I think, part of the pain. I'll talk about this. Security, they're like still kind of in the corner office. They're like, so quiet here. Well, let's make more decisions. I guess we're going to meet here in about 2 weeks to make the next set of decisions about the firewalls. And this is where the current state is that a lot of security people are not in this conversation yet, which I think they should be. Security folks also have automated pipelines. In fact, if you look at security, part of the security pipeline is a bunch of automated scripts that test a bunch of different vulnerabilities, right? They should be able to easily connect to a pipeline. They should also be able to teach other people about the security because we want to shift left. We want people to write more secure code and to have that secure code being tested. And finally, testers. Testers, a lot of testers don't know how to code yet, or they're in the process of learning it. They know how to test, but they don't know how to write test infrastructure. They know how to test, but they don't know how to coach other people. And they don't know how to work with pipelines. So these are important skills to learn in this pipeline-driven world. So I've colored the different skills, right? Red is security, blue is testing, green is development, and ops is all over. So you can see, in terms of cross-knowledge sharing, there has to be a lot of communication. So I think the problem with software, just like a very smart person named Jerry Weinberg said once, all software problems are people problems. Okay? All software problems are people problems. This is our problem. We're all trying to achieve this one thing, but everyone is doing it separately, which is why we end up with a bunch of different waterfall pipelines, because everyone stays in their own zone and their own skill, and so they create their own little bubble. So of course it doesn't work. So what's in it as testers? What can we gain by jumping into this world? Well, first of all, less stress. If you let the pipeline make a decision, it means you do not have to sign off. You do not have to say no. You can let the pipeline say no. Now, if the pipeline is green and you find a bug in production, that's pretty much what happens today anyway. People sign off, and we still find bugs in production. The only difference is that when you find bugs in production, and the pipeline was green, it means that we didn't teach the pipeline well enough, so we need to add more tests to it to find those types of problems in production. Now, there are still types of problems that I think AI will start solving, but for now they cannot be automated, and for those we'd still do manual testing or exploratory, but it doesn't have to be at a repetitive stage. And we'll talk about that in a few minutes. The second reason is job security. Job security. If we're afraid for our jobs in a pipeline-driven world, the good news is that everything is a test. A pipeline is just a big test. It's either green or red. Now, if you're in a company where there's a difference, there's something in the middle, there's not green and not red, there's like a yellow, then immediately turn that crap off. It should be either green or red, okay? Because what happens when you make a pipeline yellow, everybody looks at the pipeline and say, what the hell does that mean? And then they go immediately to the closest person who can translate, which I call a pipeline whisperer. That is the one person that knows enough about the pipeline that says, I believe this pipeline is failing. Oh, it's passing. Do not mind these failing tests. They are flaky. Product owners, okay. We shall continue. And so what's the point of the pipeline if we still need a person to sign off on it? The point is we don't trust the pipeline. We have to trust the person. So our job, as part of our job, is to create a pipeline we can trust. We also get to focus on more interesting problems instead of doing the boring stuff, the repetitive stuff. And it increases our professionalism and our hireability, right? If I get to choose what type of tester I bring into the organization, I would rather have a tester that has all of these extra skills, like working with pipelines and automation and testing infrastructure, than a tester that does not. This is going to be the new world, and this is already the world that I see people searching for. Some companies I've seen already remove the word testing from the teams, and instead introduce the idea of test architects, and I'll explain what that is. So, how do we get there? The idea of test architects is, I think it's a very interesting invention. Test architects are not specifically testers, in that their job is not to specifically do manual testing. Their job is actually much more of that of coach. In a pipeline-driven organization, everything is a test. Everyone needs to be able to learn how to write tests. Infrastructure folks need to learn how to test stuff. Developers need to learn how to test stuff. Security folks need to learn how to test stuff. Compliance folks need to learn, et cetera, et cetera, et cetera. And who has the best knowledge of how to approach testing? The people in this room. Okay? People in this room have read most of the books, know about the pyramids, they know about approaches to solving a specific issue, they know about looking at a specific problem, and then looking at it in a completely different fashion. Now compare that with a developer that has not put their time in. A developer has usually read books about architecture and design patterns and clean code and a lot of good stuff, but in terms of testing, there is very little knowledge about how to approach it. So when developers usually write tests, they're not as effective. A lot of times they miss a lot of ideas. And so what happens is that because usually those organizations don't talk to each other, they create really crappy tests, okay? Now, some developers have already jumped into the bandwagon of unit testing, and some of them are beginning to write pretty good tests in terms of unit tests. But if you ask a developer to write higher level tests, to think about the strategy of what should be tested and what shouldn't be tested, those things are usually not in their category of knowledge. They need to be, and this is, I think, where test architects come in quite a bit. So test architects help with automation, they help with infrastructure, but they're not responsible for it. That is, we do not want to create a condition where, oh, test automation, not my job, that's their job. Okay, test infrastructure, not my job. Writing the test, not my job. That's not how it's supposed to work. We want to create in that world, we want to create a better way to communicate with each other. And one of the practices that I recommend is something that I came up with, and I tried it in a few companies, and it seemed to work quite nicely. And I call it test recipes. It might seem familiar, but give me a few minutes. A test recipe is a practice. It's a meeting that ends up with a set of lines written somewhere. And that meeting happens between two people, a developer and a test architect. So before a feature even begins the work of developing that feature, this meeting happens per feature for every two people assigned to that feature. And together they create something that kind of looks like this. So this is an example of a test recipe. It doesn't have to be written on paper. In fact, most of the time what I see is that this stuff is written right under the definition of the requirement. So if you're inside the Jira story, right under the story, inside the story. Not as a set of different tasks, not as a set of lines. It's just extra text under the user story description. Maybe it's right under the feature description if you're using the given, when, then. So right under it, you'll see a few lines. Could be 10, 20, could be 30, could be 5. So each line is a scenario, and next to the line is at what level do we want to test this scenario. So the difference is, there are many differences from that and what you think this is. But this has been created by two people, not by one person, not by one person separately and then showing it to another person. It was dynamically created as a brainstorming session by two people. One of them has much more knowledge about testing approaches and how to approach the ideas, and one of them has much better knowledge about the technical details and the implementation details inside the code. And together, those pieces of knowledge create a much better test plan just for that feature. It's a mini test plan, but it's a completely dynamic one. It's not managed in a different tool. It happens during the iteration, and to complete it, it takes two people. So at the beginning of the iteration, let's say that we take the first item from the backlog. Let's see if this works. This works? Yeah, okay. Right here, there's like a 5 or 10 minute meeting between those two people that have been assigned to this feature. And then they split, and each one of them works on a different set of tests from the test recipe. So they both end up working on this. And then they meet up again in the middle, and they make sure that the test recipe is passing. Maybe it's not passing. Maybe they just want to show each other the progress. And when the test recipe is passing, then the feature is done. The process of a developer finishing the code and then someone opening a bug on that code and then fixing it as part of the iteration doesn't happen here. If the test recipe is not fully passing, the feature is still in progress. Okay? So the test recipe is part of our definition of done. And two people are responsible to make it happen. So now you're looking at this and saying, well, Roy, come on. It's a test plan. Come on. It's a test plan. I've seen these test plans. I've made hundreds of test plans. I know what a test plan looks like. But this is very different. This is written right next to the requirement. It's not managed in a separate tool. We do not have the requirement to update it with the results. We do not have to maintain it other than whenever we maintain the requirement itself. If the code changes, the test recipe is really just a big comment. Think of it like comment inside the code. It's something we can get back to very, very quickly. And a few differences as well is that it requires knowledge sharing, because this is the point where a tester can share their ideas about how to approach a specific scenario. We start with a scenario. Let's see. We start with a simple scenario, and then we decide at which level we test it. So first of all, we brainstorm about all the different scenarios. Then we decide at which level we test each of those scenarios. And for each scenario, we have to choose. So how do we choose? Well, we all know about the pyramid of maintainability, which is the most difficult at the top, right? And speed, which is the fastest at the bottom. A lot of organizations, if they have mostly a testing group, they'll end up with tests at a very, very high level. They take a long time, and their maintainability is a nightmare. And so just maintaining the test becomes a huge nightmare. These are automated tests. Some organizations are more developer-focused. They'll just end up with unit tests. Tests are run really fast, but the confidence is very low in the software. Because unit tests still do not provide the clear representation of confidence. You still want to test that everything still works together. Some organizations have miscommunication between developers and testers. So everyone works on their own stuff. Nobody knows what the other side is doing. If those at the top are failing, the ones at the bottom don't care, and the other way around. Two different monitors, two different reports. I'm sure this is not true in your cases. But this miscommunication also creates a huge problem for the builds. The builds suddenly, they have to be split. There has to be a nightly one and a continuous one. And a nightly one maybe even runs once a week, which basically means the more we run all of them, that's the minimum amount we can do continuous delivery. If I have to run all of these at the minimum once a day, then at the minimum, if everything else was perfect, it would take me 24 hours to release any patch. And that's assuming that I've solved all the other problems of people signing off on everything, etc. So here's, to me, a better representation of what I would usually recommend. We would look for these kind of high-level clothing line tests that represent the connections between the rest of the system. So you see these lights here above. They're standing on this huge pole that's keeping all of them together. So imagine that as the one test, or one or two or few tests that are very high level, and they connect all the dots together. But for every variation that I have, that I would like to test after this test is passing, I would write that variation at the lower level. So the scenarios at the lower levels are different scenarios. And I only test the variations, and I usually keep a rate of 1 to 10 for each level down. So I might have a happy case at the upper level, and then I might write a bunch of maybe not so happy cases at the API level because it's much faster and easier to simulate. And then I might write a few dozens of unit tests for much lower level, different combinations that technically, yes, I could have tested all of it at the top, but my life would be a living hell just to maintain that. So I want to manage both a higher level confidence, but a very fast feedback loop. And to me, this is a much more friendly creation that's continuous delivery oriented. Now, so this is the conversation that happens to decide which level we're testing in, right? The conversation would be, okay, do we already have an end-to-end that kind of uses this feature? And if the answer is yes, then we're probably going to go down and say, well, I'm just going to write a bunch of unit tests and an API. And then the question becomes, if all of these are passing, are we okay with the feature? Me and the other person working on this, right? The test architect. And if the answer is, yeah, if these are all okay, I'm okay with this feature, then this test recipe is done. And of course, you might discover as you work that you want to add more things to the test recipe. Just go ahead and add them. It should be very, very easy. Everyone has access to it. And when you write those tests, which should all be automated except the ones that could not be automated, they should all be in the same source control. Everyone should have access to them. It should not be in a different repository. It should not be in a different organization or a different tool. So these are the colors for it. So we want faster feedback loop. We want high confidence. But we also want the communication to happen, which is where the test recipe is a very good excuse to make everything actually kind of gel together. The test recipe is where I can actually almost force people to say, you have to work together because otherwise the test recipe is going to suck. And I've seen organizations that started out and just had people working alone, and the test recipes were not good because they only represented a view of one person, but it didn't actually make sense. So a lot of times, tests at the lower level would repeat at the high level because there wasn't communication. This is also a good way to remove duplication between the tests. So just to summarize, pipelines, they are happening whether we like it or not. We have to learn how to deal with that stuff. We have to find a way to integrate, and I think there are ways, especially in a world where everything becomes a test. So the role of a test architect is a good way to transition into that instead of looking at yourself as a tester. Think of yourself as a test architect, someone with a lot of knowledge about the application. Test recipes are one practice that you can try. There are many others. We're still in the process of discovering all of them. If you want to find out more about that stuff, my blogs, pipelinedriven.org and 5wise.com, or at Twitter at Roy Osherove. Thank you very much, everybody.